today's video is going to be looking at the different applications that we can do with surface area and volume. The first one is going to be about an ice cream scoop. So a scoop of ice cream has a volume of 230.23 centimeters cubed. If the ice cream cone has a height of 15 centimeters and a radius of 4 centimeters, what's going to happen here? So first we want to find out what is the volume of the cone. So it tells us the shape right off the bat. So I know that the volume that we're looking for is cone. So when I go to my formula sheet, I find under volume, I look for volume of cone, which is 1/3 base area times height. So the first variable we have here is big B. Big B stands for base area. The base of our cone is a circle. So big B is the area of a circle, which is pi r squared. If I look back up here, it says the ice cream cone has a height of 12 centimeters. So the height is from top to bottom. Oh, did I say 12? I meant 15. And has a radius of 4. So the radius there, which is going to be 4. So all I need for this one is my radius of 4. 4 squared gives us 16 pi. So we have 1/3 times that base area, which is 16 pi, times h. And remember, this is the height of the formula that we're in, and we're in the volume of a cone. So we're looking for the height of that cone, which is going to be 15. So 1/3 times 16 times 15. Remember, we're not going to put pi in our calculator because it'll give us decimals, and we don't want that right now, which is going to be 80 pi centimeters cubed. When the ice cream melts into the cone, will the cone overflow? Why or why not? So we have to think about what would cause the ice cream cone to overflow. We are looking at volume and not surface area, because volume is how much can fit inside of an object. So we know that the volume of our ice cream, volume of our sphere, of our ice cream here, ice cream, is 230.23 centimeters cubed. So if it overflows, we want to ask ourselves, which volume would be more, the cone or the ice cream? Which one would cause the ice cream cone to overfill with itself? So we have the volume of the cone, which is 80 pi. The problem is, I can't compare these two numbers. They both are centimeters cubed, but this is 80 times pi. There's no pi. I can only compare numbers easily if they're both pi. So what I'm going to do is I'm going to enter this into my calculator. I'm going to do 80 times pi, and I get that the volume of the cone is 251.33 centimeters cubed. So this is my ice cream. This is my cone. Which one is more? The cone has a bigger volume than the ice cream. It won't overflow because the volume of the cone is greater than the volume of the ice cream. What that means is that the cone can hold more than the ice cream itself. If the ice cream volume was bigger than the cone volume, then there wouldn't be enough room. It would overflow. All right, let's go to our next one. Next, Ashley wants to paint her bedroom walls a new color. So if we think about a typical bedroom, okay, don't get crazy here. What is a bedroom? A bedroom is a rectangle, sometimes a square. And your bedroom has walls. Ashley is painting her walls. She is not painting her ceilings. So Ashley wants to paint her bedroom walls a new color. Her bedroom is 10 feet long. So let's make this 10 feet. 13 feet wide. So 13 feet wide. And then it's 8 feet tall. So her ceilings are 8 feet. So it's 8 feet from top to bottom. We are going to paint her walls. We are not going to be painting her ceiling. We are not painting the floor. So I'm looking for the area of the 4 walls. Now, if you think about a bedroom, again, it doesn't taper off. If this side is 10 feet, this side is 10 feet. If this side over here is 13, it's 13 over here. So this front wall and this back wall, if you notice, they both are 8 feet tall and 10 feet wide. So if I'm going to paint those 2 walls, one wall is 8 times 10, because they're rectangles, base times height, which gives me 80. But I have 2 of them. So I multiply that by 2 to get 160 feet squared for those 2 walls. This wall on the right and this wall on the left, you notice both of those walls are 8 by 13. So I do 8 times 13 to get 104, but I have 2 of those, which gives me 208 feet squared. So if I'm going to be painting this bedroom, or if Ashley's going to be painting this bedroom, she's got 160 from 2 walls, 208 from another walls. In the end, all 4 walls are going to be 368 feet squared. That's how much square footage she has to account for. Each gallon of paint covers 400 square feet. So if she gets 1 gallon of paint and covers 400 square feet, how many gallons does she need? Well, she's only painting 368. 1 gallon itself covers 400. So in this case, we only need, or she only needs 1 gallon. So she bought 2 gallons. Will she need both, or will she be able to turn one? She only needs 1 gallon. She can return one. Just remember, when you are doing the painting problems, you can't buy half of a gallon or a third of a gallon. So you're either buying 1 gallon of paint, 2 gallons of paint, 3 gallons of paint, 4, 5, 6. You're not going to have decimal answers for these. All right, so we are finished.